Well, happy Monday to you. Can you believe that we have just 2 weeks until Thanksgiving? And this is your last training video of the semester. In this video, we will look at sections 4.3 and 5.1. So let's get started. Number 1, ask us to evaluate our logarithms. What we want to do with our logarithms is we want to get the base of the log to match whatever number we have here. So I can rewrite 9 as 3 squared because 9 is 3 times 3. And then once the bases match, the 3's here match, our answer is this exponent up here. And so our answer here is 2. Look at part B. We have log base 2 of 1/8. Again, I have a base of 2 for my log, so I want to get a base of 2 in the number that's written next to the log. Well, 8 is 2 times 4, and 4 is 2 times 2, so I can rewrite 8 as 2 cubed. Now notice this 2 is in the denominator of the fraction. I need to move that 2 to the top, and when I move the 2 to the top, the power changes from a positive to a negative. And now the base of my logarithm matches the base of my exponent, and so my answer here is that exponent, and so -3 is my answer. Number 2, ask us to solve our equations. We have here log base x of 1/25 equals 2. To solve this equation, I'm going to write it in exponential form. So our base is x, 2 is the exponent, and then I have my fraction 1/25. Use the square root property, so the squared goes away on the left side. Don't forget your plus or minus on the right side, and we have the square root of 1/25. Well, the square root of 1/25 is 1/5. The square root of 1 is 1, and the square root of 25 is 5. Now, one thing we have to think about is the base of the logarithm can never be negative. And it can't be 0. And so here, our only answer is 1/5. Look at part B. We have log base 3 of x equals -4. Again, to solve this logarithmic equation, I'm going to write this in exponential form. So our base is 3, our exponent is -4 equals x. To get rid of that negative power, I bring that 3 to the denominator, and the power changes to a positive. And 3 to the 4th is 81, and so our answer is 1/81. Look at part C. We have log base 2 of the 4th root of 32 equals x. Our base is 2, our exponent is x, and we have the 4th root of 32. Well, 32 is 8 times 4, 8 is 2 times 4, and 4 is 2 times 2. So I can rewrite 32 as 2 to the 5th power. On the right side, I can rewrite a root and a power as the power over the root. So this would be 5/4. So again, the power goes over the root or the index. When our bases on each side of the equation are equal, then our powers are equal. And so here, x is 5/4. Look at part D. We have x equals 4 log base 4 of 5. Now notice our logarithm is in our exponent here, but the base of the exponent and the base of the logarithm cancel out. They match, so they cancel, and we get that x equals 5. Then look at part E. We have log of x minus 3, log base x minus 3 of 10 equals 1. Our base here is x minus 3. Our power is 1 equals 10. Well, x minus 3 to the first power is x minus 3. And then add the 3 to both sides to solve for x. And we get that x is 13. Number 3 asks us to use the properties of logs to rewrite our expression. So we have log base 3 of x squared y over z to the 5th. With our properties of logs, basically anything in the numerator gets a plus in front, and anything in the denominator has a minus in front. And so I write this as log base 3 of x squared plus log base 3 of y plus log base 3 of z to the 5th. And then our exponents come to the front of each of our terms. So we have 2 log base 3 of x. I can't do anything with that second term. And notice here I did make a mistake. That z is on the bottom, so this should be a minus. And the 5 comes to the front. And we have log base 3 of z. And that's our final answer. Look at number 4. Also notice here in number 3 that each term has that log base 3 in it. So look at number 4. We have 2 log base 2 of x minus 3 log base 2 of y, and we're asked to rewrite this as a single logarithm. The coefficient of the logarithms becomes our power. And so this would be log base 2 of x squared minus log base 2 of y cubed. Then I write my log base 2. The x squared is positive, or that term is positive, so the x squared goes on top. The term with the y cubed is negative, and so the y cubed goes on bottom. And if possible, you would simplify from there. Now 1 through 4 focus on our logarithms. Number 5 looks at systems of equations. There are 2 ways to solve systems of equations. One is called substitution and one is called by elimination. I prefer elimination, but I'm going to show you substitution as well. The substitution really only works if we have a variable that has a coefficient of 1, like we do in part A. So with substitution, the first thing that I want to do is solve this equation for y. So I'm going to solve the equation for whatever variable has a coefficient of 1. Add the x to both sides. And we get that y equals x plus 5 or 5 plus x. My second step is I substitute in. So I'm going to use the other equation. And I'm going to substitute that y. So y is x plus 5. Then my third step is to solve this equation. So distribute your 3. Gives us 3x plus 15. Put your like terms together, gives us 7x. Subtract the 15 from both sides. Divide both sides by 7. And we get that x is -4. When we're solving a system of equation, we're going to have an ordered pair, so we'll have an x-coordinate and a y-coordinate. Now that I've found x, I need to find y. And I'm going to go back to my original equation, and I can use either one of my two original equations. I'm going to choose the second one. And plug in -4 for x. Negative and a negative makes a positive. Subtract the 4 from both sides. And we get that y is 1. The answer should always be written as an ordered pair, and the x comes first. And so our ordered pair here would be the point -4, 1. So let's look at part B. Notice that part B does not have a variable that has a coefficient of 1. We have 2x minus 3y equals -7 and 5x plus 4y equals 17. I want to eliminate one of my variables. This is our other method. Now, typically I choose a variable that has a plus in front of the variable in one equation and a minus in front of the variable in the other equation. And so I'm going to look at the y's. If I multiply the top equation by 4 and the bottom equation by 3, notice distribute the 4, we get 8x minus 12y equals -28. And we have 15x and plus 12y equals 51. So when I add these two equations, these y's are going to cancel out. You always want to try to multiply by a number so that one of your variables is eliminated. Well, 8x plus 15x is 23x. And -28 plus 51 is also 23. Divide both sides by 23. And we get that x is 1. Now we need to find our y. And to find y, I can plug 1 into either one of my two equations. And I always go back to original. I'm going to choose the first equation just because it's the first equation. Plug in 1 for x. And solve for y. 2 times 1 is 2. Subtract the 2 from both sides to get that y by itself. That gives us -3y equals -9. Divide both sides by -3. And we get that y is 3. And so our ordered pair here, the x always comes first, would be 1, 3. When you check, you plug in 1 for x and 3 for y, and it should check in both equations. Now look at part C. We have 9x minus 5y equals 1 and -18x plus 10y equals 1. I can eliminate either one of the variables. I'm going to choose to eliminate x this time. So if I multiply the top equation by 2, that gives me 18x minus 10y equals 2. And I'm going to bring down that second equation. Add your two equations here, and notice that the x's and the y's cancel out. So we're left with 0 on the left side, and we have 3 on the right side. This does not make sense, and so we call this an inconsistent system. it has no solution. Last, let's look at part D. I can eliminate x or y. To eliminate x, I would need to multiply the top equation by -3. When I distribute that -3, I get a -9x minus 3y and equals +6. Bring down that second equation. And then add your two equations, and notice again that the x's cancel as well as the y's, and that leaves us with 0 on the left side and 0 on the right side. Now, rather than saying that this one has all real numbers as our answer, we say that this one has infinitely many solutions. Now, Math Labs has some specific directions when we have infinitely many solutions. Math Labs ask us to write the solution set with an arbitrary x. So that means my x-coordinate is going to be x, and I need to write that y-coordinate in terms of x. So that means I'm going to solve for y. Now, if the directions ask you for an arbitrary y, you would solve for x, and you would write everything in your ordered pair in terms of y. I can choose either one of my two equations. I'm just going to choose the top equation. So we have 3x plus y equals -2. And I'm going to solve for y. So subtract the 3x from both sides. And we get that y is -3x minus 2. And so my y-coordinate here would be -3x minus 2. Well, I hope these training videos have helped you throughout the semester. Thank you for all that you do with us, and for the help that you give our students. As always, if you have any questions, let me know. Good luck to you in the rest of your semester, and I know the exams will be here before we know.